Force. Today let us understand what is force. The word force is used to describe a push or a pull. For the force to come into play, there has to be interaction between two objects. What do we do when a car is not working? We need to push the car to move it. Hence there is an interaction between the car and the person pushing it. Therefore, a force is applied by the person on the car. This results in the motion of the car. Force comes into play due to interaction. Interaction of an object with another results in force between two objects. The force is a measurable quantity. Its SI unit is Newton, and is denoted by N. Types of forces. Force is broadly classified into contact forces and non-contact forces. When there is actual physical contact between two bodies, the force experienced by them is known as contact force. For example, look at the picture, where the man is pushing the car. Both the car and the man are in contact physically. Some examples of contact forces are masculine force and the frictional force. Two men pushing a box is an example for masculine force. Here force is exerted due to the action of muscles. Let us understand what is a frictional force. Observe the diagram. Here a box is in contact with a surface, say floor. As we try to move the box by applying masculine force, the frictional force between the box and the floor tries to stop its movement. Frictional force is a contact force. Direction of frictional force is opposite to the direction of motion. Non-contact forces are the forces experienced by bodies, even if they are not in physical contact with each other. Magnetic force, electrostatic force, and gravitational forces are examples of non-contact forces. Few iron nails kept near a magnet move towards the magnet. This is because of the magnetic pull exerted by the magnet on the iron nails. Similarly, a charged body attracts small objects because of electrostatic force of attraction. A stone thrown from a height falls onto the ground because of the gravitational pull of the earth. In all these instances, there is no direct contact between two bodies, but even then there is motion of objects. Such type of forces are known as non-contact forces. They are also known as action at a distance forces. Effects of force. Here, a man is pushing a car. He is applying force to make a stationary car move. This wicket-keeper is trying to catch the ball hit by a batsman. In this case, the keeper applies a force to stop the ball, which is moving. By these instances we can make out that a force can change the state of motion of a body. That is, a moving body can be stopped, and a stationary body can be moved by applying force. A force can also change the direction of motion of an object. For example, a bowler bowls the ball towards the batsman. The batsman hits the ball with his bat. That is, force is applied on the ball by the bat. Hence the ball changes its direction of motion. Go to the kitchen and observe the dough prepared to make roti. As your mother presses the dough, it changes its shape. By this you can infer that a force can change the shape of an object. Certain materials are elastic in nature. Such materials can be stretched to different sizes. Look at the picture. Here, a rubber band is stretched by fingers. So a force can even change the size of an object. To summarize, a force can make a body move, can stop a moving body, can change the direction of motion of a moving body, can change the shape of an object, and can change the size of an object. Unit of force. The SI unit of force is Newton, and it is denoted by N. As you know, force, F, equal to mass multiplied by acceleration. On substituting the SI units of mass and acceleration, that is, 1 Newton equal to 1 kilogram multiplied by 1 meter per second square. Hence 1 Newton is the force, which when acts on a body of mass 1 kilogram, produces an acceleration of 1 meter per second square. The CGS unit of force is N. As discussed, force F equal to mass multiplied by acceleration. On substituting the CGS units of mass and acceleration, we get 1 dyne equal to 1 gram multiplied by 1 centimeter per second square. Hence 1 dyne is the force, which when acts on a body of mass 1 gram, produces an acceleration of 1 centimeter per second square. This is the relationship between Newton and dyne. 1 Newton equal to 10 raised to the power of 5 dyne. Pressure exerted by a liquid column. Let us discuss about the pressure exerted by liquid at a point inside the liquid. Look at the diagram. Here a beaker is filled with water. The area of the free surface is considered as A, and depth is h. Pressure exerted at a point inside a liquid, which is at a depth h, from the free surface is given by P equal to h, multiplied by ρ, multiplied by g, where ρ is the density of the liquid, and g is acceleration due to gravity. By this formula, you can easily make out that the factors which affect the pressure at a point inside a liquid is h, ρ, and g. Acceleration due to gravity is constant, and hence the pressure exerted depends upon the density of the liquid and height from the free surface. As you move down the liquid, h increases, and hence pressure also increases. Let us look at some of the examples. The walls of a dam are made thicker at the bottom. In case of water supply tanks, it is placed at a good height to get more pressure at the taps to ensure good supply. However, pressure does not change with the shape and size of the container.
Force and pressure. Summary. Force. Force comes into play due to interaction. An interaction of an object with another results in force between the two objects. For example, car being pushed by a man. Effects of force. For example, girl pulling a chair. It can change the state of rest or motion of the body. It can change the size or shape of the body. Force changes the state of motion of a tire, makes it to move faster. Box at rest moves due to force. Force applied by hands on the dough changes its shape. Force changes the size of a rubber band. Combining forces. Forces in the same direction. If forces are applied in the same direction on an object, the net force acting on it is the sum of the forces. Net force equals 80 plus 60 equals 140 N. Forces in the opposite direction. If the forces are applied in opposite directions on an object, the net force acting on it is the difference between the two forces. Net force equals 60 to 50 equals 10 N. Object will move in the direction of the greater force. Net force, the force acting on an object, after all the forces are combined. The net force on an object is 0 if the forces acting on it in opposite directions are equal. For example, the rope will not move since net force is 0. 5 equals 0. Types of forces. Contact forces. Forces experienced by bodies when they are in physical contact with each other. Muscular force due to the action of muscles. Frictional force acting opposite to the direction of motion. Non-contact forces. Forces experienced by bodies even if they are not in physical contact with each other. Magnetic force exerted by a magnet. Electrostatic force exerted by a charged body on another charged body. Gravitational attractive force exerting between two objects. Pressure. The force acting on a unit area of a surface is called pressure. The force applied on the surface is perpendicular to the surface known as thrust. Pressure depends on two factors. Force, more the force applied, more pressure. Area, greater the surface area on which the pressure is applied, lesser the pressure. Lesser the surface area, more the pressure. Pressure examples in daily life. School's bags have wider straps. Sharp knife cuts better than blunt knife. Buildings have wider foundation. Easier to walk on sand with flat shoes rather than shoes with sharp heels. Pressure exerted by liquids and gases. In liquids and gases, molecules have space between them and they are randomly moving in all directions and collide with one another. Hence they exert pressure on the walls of the container. Liquids exert equal pressure at the same depth. For example, fountains of water coming out of the leaking joints or holes in pipes. For example, pressure exerted by water at the bottom of the container depends on the height of its column. For example, balloon gets inflated due to pressure of liquid on the walls of the bottle. Puncture in tires, air exerts pressure on inner walls of tube. Atmospheric pressure. The atmospheric air extends up to many kilometers above the surface of the earth. The pressure exerted by this air is known as atmospheric pressure. Atmospheric pressure is the weight of air in a column of unit area. Atmospheric pressure is measured by barometer. Atmospheric pressure decreases as the altitude increases. 1. We get earache when we travel by airplane. When the airplane lands, air pressure increases, which increases pressure on eardrum, causing ear pain. 2. A rubber sucker pressed on a surface sticks to it. When sucker is pressed, air between surface and sucker moves out. Outside there is atmospheric pressure acting on it, so it sticks to the surface. 3. When drinking with a straw, one has to suck the straw. This causes the pressure in the straw to decrease. The external atmospheric pressure, which is greater, will then act on the surface of the water and the glass, causing it to rise through the straw.